Okay, let us see this example now. We are now going to see how do we get, we have been seeing when they give you displacement, how to get acceleration and velocity. Now with what if they give you acceleration, how do you get these velocities and then displacement? Okay, a particle starts from rest, it means that when it is 0, that's when the particle is. At the origin, 0, 0, its displacement, its acceleration after time t is given by this meters per second. Find the speed when t is equal to 2. So this is our acceleration in meters per second squared. So that always our speed is equal to magnitude of velocity. But you know if they give you acceleration and they need velocity, but know that our velocity is equal to the integral of acceleration. Of course, to determine this, we shall add a constant of integration. So from here, we can now our acceleration, which we can give in a column form as 16, then minus 4. As simple. This one, I think it's very easy to integrate. Even if you take it the way it is okay. No problem. So, from here, if you put it there, now we are getting velocity at time, at any time. It's going to be now integral, or you can put this, or you can put this. It's up to you. So, it's going to be, okay, let me put this one, 60 minus 4 dt. Of course, you shall get a constant of integration, but you can handle it at once if you want, but we shall see that later. So then if we say 60, you increase the power by 1 divided by the new power. So our velocity at n time t is going to be, this will be now, okay, 60 squared over 2, then this will give us negative 40, then plus c. So to simplify there, our velocity at n time is going to be, now this will give us 3t squared minus 4t, then plus a c. But you can skip this step because you know that this one you are going to divide. You increase the power by 1 divided by the new power. As simple as that. When you integrate a constant, you get that value there. T. So now we need to know what this constant is. So then we put in the conditions. When t is 0, remember the particle was at rest at the origin at the start. So it means that now it was having 0 velocity at rest. As simple as that. So when you put in, now you can get this here. So RD, when time is 0, is equaling to 0. Which will be now, we put in, where it is 2, we put 0. So we have 0 squared then negative 4 into 0, then plus c. What does it imply? It implies that now our c, because this is going to be 0. So it implies that our c is going to be 0. So writing this again, our dt now will be 3t squared and negative 4t with is. So now they want us to get speed when t is 2. When t is 2, we can get now our v2 as 3 into 2 squared, then negative 4 into 2, which will give us, of course these are meters per second. This will give us 4 times 3, which will give us a 12, then this will give us negative 8. Okay, which we can write as 12i minus 8j meters per second, because that's velocity. Now our speed, so means that our speed, which the one is going to be magnitude of v2, which will be magnitude of 12 squared plus negative 8 squared. And so from there, our speed after 2 seconds is going to be 144 plus 64, 14.422 meters speed is the magnitude of velocity. Then part B, they need to get distance. So in our part B, we know that our distance is always equal to magnitude of displacement. So how do you get our displacement? So that our S is equal to get displacement, we integrate B, integrate our velocity with respect to T. As simple as that. So, of course, plus a constant of integration. So our S here will be integral. What was our B? At any time, it was this. So we have now, you can give it, this one is the same as 3t squared I minus 4tj meters per second. Either you give it, you can also interpret it in this form. It's up to you. You can say this is going to be 3t squared I minus 4tj dt plus a constant of integration. From there, you can simply see that when you integrate this, we shall get t cubed, increase the power by 1, divide by 3, so we will cancel I, then minus, this will be 2t squared, then plus c. So that's our displacement at any time t. When t is 0, the displacement is still 0. So if it was at the origin, it had covered 0, this 0, it was displaced 0. It had a 0 displacement. So when we put in there, our S at 0 is going to be 0, implying that 0 will be now 0 cubed I minus 2 0 squared, then plus t, implying that our C is 0. Don't take it that always is 0, no. Just for this question, that's what we are aiming. So meaning that now our S at any time is t cubed I minus 2 squared j meters, which we can give as t cubed minus 2t squared. Really easy. So from there now, we can get after the distance, the displacement after 3 seconds. When t is equal to 3, what do we have? I don't want them to be too close. Okay, when t is equal to 3 seconds, now S of 3 is going to be, you can substitute here or here. It's up to you. Okay, it's going to be 3 cubed minus 2 into 3 squared. 3 cubed, that's 27. Then this is 9 times, that's negative 18. So our distance is going to be modulus of this, which will be now square root of 27 squared plus negative 18 squared, which will give us 32.44.45. It's 0.45 meters. So this is the distance after 3 seconds. So that's how we handle that. I wish you well.